we know that all moving objects possess energy. Uh, for example, let us say this is the ground level and there's an aircraft flying at this particular height. So this is the height, and let's say it is moving with velocity v. Right? So this aircraft will possess kinetic energy because of its motion and potential energy because of its height. Right? In the same way, right, if you have a flowing liquid in a pipeline, so let us say this is a pipeline, and let us say there is liquid inside this which is flowing in this direction with velocity v, and let us say it is this particular liquid pipeline is at a height h from the ground level. This is the ground level. Right? This flowing fluid will also possess energy, and we are going to look at various energies that this fluid possesses. The first energy that we will look at is kinetic energy. Right? Kinetic energy. Kinetic energy will be given by half m v square, where m is the mass of the liquid and v is the velocity with which this liquid is flowing. Right? And if I find out kinetic energy per volume, right, I'll get half mv square divided by volume. Right? And we know mass per unit volume, or mass per volume, is density, so this equation will be half rho v square. Therefore I get this first equation: kinetic energy per unit volume is equal to half rho v square. In the same way, if I look at potential energy of the liquid, it will be given by mgh. And if I find out potential energy, if I denote this by u, and if I find out potential energy per unit volume, I'll get mgh by v. Again, m by v is density, so this will give me rho gh, where rho is density, and therefore I get the second energy, potential energy per unit volume, is equal to rho gh. This is equation 2. The third energy. In case of liquids, the liquids possess one more type of energy, which is known as pressure energy. Pressure energy. And they possess pressure energy because of the internal pressure in the fluid. Right? So we know that these molecules of the liquid move in random direction. Right? They collide with each other. They collide with the boundaries. Right? Some of them will collide over here. Some of them will collide with each other. Some will be colliding over here. So if I take any particular point, pressure will be created because of these collisions, and the pressure will act in different directions. And it will act in all the directions. Right? And if I take a unit area, let us say I take this particular unit area over here in this liquid, then this will be subjected to pressure in all different directions. Right? All different directions. And let us say the net pressure due to these different pressures is, let us say, P. Right? So this particular unit area is subjected to pressure P, and because of that it is subjected to some force F. Right? So because of this pressure there is a force F acting on this particular unit area. Coming back over here, pressure energy. Pressure energy will be given by work done, because energy is work done. Okay? And work done by the force due to internal pressure of the fluid, internal pressure into distance or displacement. Coming back over here, because of this force which is acting on this unit area will get displaced this direction or in some random direction depending upon the direction of the net pressure acting over here. So this will get displaced, and let us say the displacement is L. Right? So this is force due to internal pressure, and displacement is, let us say, L. Right? Now this force is the force due to internal pressure, therefore it's given by pressure into area. This force which is acting is pressure into this unit area. Okay? So pressure into area into L. So therefore pressure energy of the liquid will be given by P into A into L, and pressure energy per unit volume will be PAL by volume. Now what is the volume of the fluid or the liquid that we are considering over here? It is cross-sectional area into the displacement L. So volume will be A into L. A, L will get cancelled, and I'll get P. And therefore Therefore, I'll write down pressure energy per unit volume is equal to the pressure of the fluid, right? And this gives me the third energy. Right. So let us summarize what we have discussed. Right, a flowing liquid possesses three energies: kinetic energy, and kinetic energy per unit volume is given by half rho v square, where rho is the density of the fluid and v is the speed of the liquid. Potential energy per unit volume is given by rho gh, where rho is the density of the fluid, g is acceleration due to gravity, and h is the height of the mass of the liquid. And finally, pressure energy of the liquid per unit volume is given by the pressure of the liquid. Right? So these are the three energies that a flowing liquid possesses. Thank you.